Yeah, thank you very much. We want to talk about footnotes today and how LLMs or other algorithms are struggling with it. But the title is a bit more involved. It's about law and humanities scholarship, which uses a lot of footnotes, and what we need in order to parse them. Oops. Okay, the research question. I won't present you the research question that I started or we started with because we're making a big detour to produce the kind of data that we need to answer our research questions. And what we need are citation graphs. And citation graphs are obviously quite useful in the history of science or intellectual history generally to discover patterns and relationships in knowledge production. And we can look for influences and measure the reception of ideas that have been published. And one obvious example is for example, to look for most cited authors over time. And I have an example here from the Journal of Law and Society in a specific time frame. And if you visit the slides that are online, you can click on it and have a nice interactive web application to show it. But what's our problem? The first problem is that, and we already talked about bibliometric databases, for the domain that we're studying, these databases are crap. Basically, that's it. You cannot use them. They don't have the data that we need. The three have already been mentioned. And on top, and I need to emphasize this, Web of Science and Scopus are extremely expensive and have very restrictive licenses. We should move away from these databases. They are not open. They don't have the data we need. And our OpenAlex is much better because it's open access, but it doesn't also, for the kind of stuff that we need, doesn't have it. They don't cover a lot of they are focused on journals. They lack stuff for the pre-digital age, and they typically lack stuff that is not in English. Just an example for what I'm interested in, the Zeitschrift für Rechtssoziologie, Journal for Law and Society, the German journal. You can see coverage improves kind of after the 2000s, but before that, there's nothing. And why is that? First of all, of course, because there's no money to be made with humanities scholarship as opposed to STEM and medicine and economics, which is typically in the big bibliometric databases. These databases focus on the impact factor, which I'm not interested in at all. I'm interested in intellectual history. Then, of course, the thing is that the literature that we're interested in typically has a lot of footnotes. And here we have one example, footnote from hell, a typical humanities footnote with all kind of commentary, messy stuff, and it's all embedded in a lot of noise. If the traditional instruments that we have, you need to kind of, in a very laborious process, create kind of annotations for that. But even if you have these annotations, and we did them, we spent a lot of time on these, the traditional tools that rely on conditional random forest and all the machine learning stuff, they don't perform. I have one example here, but it's the same thing for the other tools as well. So do the LLMs help us? Well, if you just do kind of anecdotal ad hoc experiments, it's already the very early models performed quite well. So newer models are even better, and then we have VLMs, so we can process PDFs, and we have all kinds of methods to deal with this that we're just starting to look into. But you all know the problem. How can we trust the results? So we don't want to do any analysis unless we really know that the results are correct. And I think this should be a general principle. Don't try to solve problems that you don't have any validation data for. So we need robust testing and evaluation. So we need gold standard. We need a flexible framework that can be adapted to a very highly evolving technology landscape. And we need testing tools that make the results comparable to other solutions that we come up with. And so with that, I pass to Andreas.
Thank you. So what we tried was to compile a list of training data that we could also use as evaluation data. And we decided to do it with an TI-XML encoding, which might not be so customary in the LLM and current machine learning circles, but in the humanities and in text-based humanities, in digital editorics, that's really the most popular and most important standard to follow. So, and more concretely, what were our reasons for choosing this? Because TI-XML is a well-established and well-specified standard. In contrast to more bibliographical standards like CSL or BibTeX or something like that. This covers a lot more of phenomena, and thus it also goes beyond mere reference management. It could also encode the context, which many bibliometric projects are interested in to classify the citation intention, for example. But also we could use it to tap editions, text collections, and corpora that already exist, because many digital editorics projects, they publish their source data as TI-XML, and eventually they may have TI-XML detailed encodings of their references. Also, we can use this if we can get a hold of such corpora. We can use them for testing our own mechanisms, generalization, and robustness features. Still, there are some problems with the standard, some conceptual and some technical, but I will skip over that. We have, or we are in the process of establishing this data set. Here you can see on the left a footnote, the footnote number 4, and we have several stages in which we encode this. So you can see the screenshot of the PDF. The screenshot on the upper right, which is difficult to read, just segments the reference string from that part of the footnote, which is not a reference. Here, the footnote begins with "see also the debate between," and so and so. And in the footnotes, that's very often the case that you have lots of text which is not actually reference strings. And then you have the past, another stage of the data set where you have the past structure, data structure. The thing is that we have changed our the strategy of building this data set somewhat midway, where in the beginning we have worked with a data set that was more relevant to the research question that Christian had. We decided more recently to go to also supply the PDFs and be able to make use of the VLM mechanisms, and thus we wanted to be able to publish the whole data set from the PDFs until the data structures with the parsed references. So we changed to open access available journals, and we are now coding more than 1,000 footnotes from 20 articles in several languages from a large time span, which presumably have more than 1,500 references, which often are the same work that is referenced multiple times. But as we are interested also in the occurrences, in what context is it mentioned, we encode these separately. Again, to come back to another reason for the for the TEI XML standard. One benefit of using this interoperable standard is that there is lots of tooling available for it. And one of the most important tools for our immediate use case is Grobit, which is a popular tool for reference and other information extraction. And they are using TI-XML for their training and evaluation. So using the same data format, we can then compare our performance to Grobit's performance. We can also use Grobit's training data to train our mechanism, and we can also provide our data to the Grobit team so that they can benefit from it. That being said, the question is, what actually do we mean when we talk of performance? And thus I pass to David.
Thanks. Okay, so now it's my turn. So for this project, we created LaMode, which stands for Large Language Models for Reference Extraction. And it's basically a small Python package that can do two things. So you can provide a text or PDFs, and you will get back references, which you then can export as TEI formatted XML files. And if you have gold references, you can get back an evaluation of the extraction performance. We had two main objectives in mind when creating this package. So first, it should be lightweight, meaning LaMode does not contain any model, but it's rather an interface to a model of your choice. And as such, we also wanted to ensure the compatibility to open and closed LLMs or VLMs. This is a small primer of how this tool or this package works. So it's on Pipey. You can simply install it via pip. And then for the extraction part, you define your extractor, depending on the model you want to choose. With the OpenAI extractor, we basically cover all the compatibility to the open models, because most of the open model serving frameworks like Ollama, VLLM, and so forth, they all provide an endpoint, an API that is compatible to the OpenAI one. And then you give a PDF or a text to this extractor. You get back references, and these references you can export to an XML file. For the evaluation, you would import this F1 class and then provide it with the gold references and the extracted ones. Now a couple of slides about the evaluation, how we do it, how exactly we do it. So the F1 score is a well-established metric when comparing structured data. You define your precision, your recall. In our case, it's the number of matches. So in this example below, you can see there are 4 matches, so analytic title matches, monographic title matches, the surname matches, and the publication date. Forename is a little bit off. You have this extra dot there in the gold reference. And then you divide the number of matches to the number of predicted elements. So in this case, it would be 5 elements in the extracted reference, and in the gold reference, there are 6 elements. And then you simply compute the harmonic mean between the two values, and this gives you your F1 score. And an F1 score of 1 means perfect extraction, reference perfectly extracted, and F1 score of 0 means there were no matches, basically. Okay, now we can compare 2 references, but we still have the problem of aligning the the references. So when we provide a PDF to the tool, we get back references, but then we have to decide, okay, which one of the references do we have to compare to which one of the gold references? And here we tackle this problem by turning it to a so-called unbalanced assignment problem. There are a lot of solvers for these kind of problems. We use this internally. LaMode uses the one from SciPy. And you basically compute all the F1s for each of the combination. So you compare extracted reference 1 to all your gold references and so forth, and then you construct this matrix. And then you try to maximize the total F1 score while ensuring a unique assignment. And then you have the assignment, then you can basically add your F1 scores and macro average them. And here we penalize, like, for example, missing references with an F1 score of 0, as well as hallucinated references.
I'm sorry, you have to come to the end. You didn't see my 1 minute.
Oh, sorry. Okay. This is very similar. Just one comment. This is very similar to Buckes et al. In a publication they did last week. So the question is, does it work? So we took the dataset plus 1,000, which are 1,000 PDFs from the biomedical field, and we see that we perform more or less as Grobit in this kind of dataset. Grobit was trained on parts of these kind of journal articles, but of course, if you take into account efficiency resources, Grobit is far superior because in Gemini, the amount of compute is orders of magnitude larger than Grobit. However, if we go to our data set, Grobit really struggles to extract the references, and we see that our approach performs significantly better. And yeah, I don't know.
Thank you very much.
It's okay.
Yeah, maybe leave it like that. And is it one slide or more slides?
It's okay.
Cool. Nice. Okay, so there's the first one over there. Can someone help me with the mics? Cool.
Yeah, excellent talk. This is very close to kind of my passion because I've developed LLMs for document intelligence. So there's a couple of comments I'm going to give and also a couple of questions. And also I'm going to answer, Andreas, your comment about earlier because I work with a funding agency for bibliometric databases. So I'll try to remember everything. One, my first question is for evaluation metric. When you have the F1 score with the match, is that match an absolute match or a partial match? Is it a spurious match or a missing match? There's 5 different match systems, right, in an entity recognition metric system. So what type of match is it? Because you can imagine for reference matching, some type of match, even if it's not a perfect match, still will be useful, even if it's spurious. So that's my first question. Second question is, when you look at vision language models, I'm going to make an assumption, and you can correct me if which I probably will be wrong, is that you're probably looking at a modality of just the image, a PDF of the image, and the raw text. In my past experience and in the literature, it's been shown that actually if you use a different modality instead of image, but you use the layout orientation. So you discretize the layout into the actual tokens themselves and you use that as a modality, because essentially in PDF, when you're trying to work with PDFs, you're not trying to look at what the PDF looks like. You want to know where the text is, right? The references are in the footnotes, you know where the orientation is, and that's what's actually informing the model. So I think you could get better F1 scores in your matching if you were to discretize the orientation into the tokens, not using the image. So it's like you're getting more of a direct look at where the footnotes are. And my comment about sorry, I'm trying to remember everything I was trying to say. Oh, to answer your comment about Andreas earlier, I think because OpenAlex came from Microsoft, right? When Microsoft couldn't support Microsoft Academic Graph, that was the origins of OpenAlex. A nonprofit organization came and started to support that system. So there's some hope that like it's of interest to the academic community that even if a commercial entity like Microsoft couldn't support it, there is some interest behind that. I would say the more of a danger than AI-generated papers or retracted papers. Actually, there's now a rising evidence that fraudulent papers from paper mills are actually overpopulating open source databases like OpenAlex. I would say that's actually the bigger issue at play. And then, sorry, I'm trying to. I'm going to stop at that. I'm going to stop at
that.
Yeah.
Okay. So to your first question, this was the exact match. Yes, like these metrics are exact match. Actually, the tool, you can see there the Levenstein distance as an argument, so you can decide if you want to allow for certain Levenstein distances. Valid point. I mean, sometimes you don't need an exact match, right? And to your the second question was, for sure, there is a lot of room for improvement. Like these F1 scores are not good at all. So this is a very vanilla approach. Like we just send the PDF, the text to a pre-trained model. And of course, if you fine-tune something, if you include more stuff, then for sure this will get better. And I don't know.
Yeah, and about the third question, I think it's very important to keep this in mind, but that's why I'm saying it doesn't make sense to download OpenAlex completely and then think something will come out of it. The burden of quality assurance falls on you, whereas in Web of Science and Scopus, you kind of outsource it to these companies, which do what they think is best, but it might not be the best for your research question. So we should be very suspicious in different ways towards OpenAlex and Web of Science and Scopus.
Thank you for the talk. Am I next? Did someone else? Okay. I just wondered if you, maybe following up a little bit on this question, were you able to disaggregate why the matches didn't work? What aspect of the process? So what would be interesting is, was it due to an OCR error in some cases, or was it due to not recognizing the proper structure in the footnote? I mean, how fine-grained can you disaggregate the errors you're counting from? Because you can imagine using this in other scenarios where maybe OCR would be much more difficult to parse, but you could still get the structure. I mean, I don't know exactly the different applications, but are you able to see that, or is it really just here at this level, these work, these do not work?
I mean, the reason why Grobit doesn't work is easy to answer because it's just totally out of distribution of its training data. So we didn't do a full-blown error analysis, I would say, for the extracted ones by the VLMs. Yeah, I would say like these footnotes are really hard. Like I'm not from the humanities, and I couldn't extract the references from these footnotes. So I definitely see that if it's a footnote, it's very complicated, even for me, then the LLM also struggles to extract the references. But yeah, it would be interesting to know what the failure modes are exactly. Yeah.
Just a brief bit. I have some. Whoop. There it is. You have citations where it's not clear if the first number, for example, if this is a volume number or a page number and something like that. And that's difficult for human readers too. And while I do only have anecdotal evidence, these are typical errors that we see again and again. Capitalization is misleading, and you have personal names appearing in titles that are then being identified as authors just because it's the name of a person. And you have the special terminology which the language model is not acquainted with, so that idem or derselbe is being classified as an author while it's only referring to an author that has been mentioned earlier, and these kind of errors are very, very frequent.
Is it okay if we collect now 3 at once and then you answer? Okay. So it's in sequence Raphael, Sophia, and Gerd.
Hi, thank you for the very interesting talk. So you mentioned that you wouldn't do analysis before you had a gold standard set that is good enough. And my question would be, what is good enough? I mean, what F1 score do you want to have? And I mean, isn't it also kind of dependent on what you actually want to get out of your analysis? So, I mean, a low one could be for one question. If you're just looking for tendencies, a low one could be good enough. And for a very accurate one, you have to have a high one.
Thank you. Now, Sophia.
Thank you. My question is related to citations. Since the citation signal is vulnerable to non-academic factors such as popularity, have you thought of enriching these relationships in some other way through another method?
Now, Gerd, is there a microphone over there? Or? Okay.
looking at the descriptions of the fields in the GitHub repository, I see that basically, if I'm right, you match the phrases of the particular items in the bibliographical reference, and you compare it with the gold standard as a pattern to compare with. Do you have other validation mechanisms in your mind? Because you compare it with Gropit, but at one stage of their versions, for example, they compared their results with bibliographical databases. When you add that step, you get much better scores for Gropit. So it's they are not as bad as you showed them in my history of using it. But it's due to some sort of validation procedures, as I've just talked about, as far as you can push the validity and the quality of the data.
Yeah.
Thank you.
Yeah. I think that's this idea was mentioned on one of the early slides with the retrieval augmented generation. When we know what discipline and what discourse this is from, we might have a bibliographical database that we assume the results would come from, and we might reconcile against this or something like that. So we have thought about it, but we didn't implement it yet. And with regard to the first question, I think that's really a tough one for us because we have somewhat divergent goals among ourselves. Christian has his project and wants to have a result for his research question. And I'm interested in making this generic so that it can apply to other projects. And so there are always these different divergent goals somewhat contending, and there's no single answer to when will be pragmatic and in what way, and when will be spending effort that might not be necessary at the moment. So, do you want to add something? I didn't quite get the second question.
Yeah, maybe the second question with the signal word. Can you repeat it?
Yes, related to the citation signal, since it is vulnerable to non-academic factors such as popularity.
To what? To
the citation signal?
Yeah.
How do you enrich the relationships since this is vulnerable to non-academic factors such as popularity?
Like when they say C completely wrong, Miller 2007, is that what you mean, or?
Let's say not only footnotes, but any other text that is citing other papers because they are what's considered popular shared knowledge, but not necessarily the, let's say, most important paper.
Okay. But that's not our concern at the moment. It's just like descriptive in a sense. We want to know who was cited, and then the later analysis will interpret that result. So we're just interested in who was actually cited in, for example, the Journal of Law and Society in this time period. So, and then as an additional step, and I think this is also the question is if you're interested in extraction versus in context, because if you're just interested in extraction, then this concerns the question, what is good enough? Then it's probably good enough if you have 90% or 95% right, and you don't have any false positives. And I think this also is the question. If you use the traditional tools of machine learning, you just had false negatives, like it didn't find something. But with the LLMs, the problem is that you will have false positives by the LLMs inventing some citation that there isn't. And that's why I don't want to go big or scale up until I know that a certain model, given a certain prompt, will actually provide reliable results, because otherwise my data is crap. And then I don't want to be interpreting that data. But of course, if you just have the ambition to extract, to have tendencies, was Habermas cited more in the 1970s or in the 1960s or something like this, then you can work with less reliable data, although you still need to know how representative your data is. And the question of like, is it enough to just have the title and the author, and then you can do a fuzzy search in bibliographic databases? Then you don't need to have like an exact match. That's true, but we're at a stage where we want to first have like reliable results also in order to be able to get all this contextual stuff. Like, for example, was it cited approvingly or not approvingly? We're not doing this at the moment, but that's kind of the goal, to get like more out of it than just the extracted reference string.
Can we have one more comment, or do you want to answer to something else?
No?
Yeah, okay, because yeah.
Thank you. So did you think about a human in the loop approach? Like you have mentioned how difficult is the annotation, but probably fixing the errors is simpler than annotating from scratch. So you can use these models to pre-annotate the data and then put a human in the loop, fixing the errors and produce new high quality data that can be used again to better improve the model every time, like an iterative process.
To be honest, the workflow for establishing the data set is not so solid. So we are experimenting with that a bit. We have already tried this and used Lamore to produce the structured data that we want, that we could then correct. But also, that's my idea. The data set is more generalizable and more useful if you have these intermediate stages where only the referring string is marked and not passed yet. And this is something that Lamore, if I'm correct, does not output at the moment. So at least for these other stages, intermediate stages, there's more effort, manual effort required.